What's up? I'm Vin, and I'm going to go through the 2023 New York Math Test for Grade 4, and I'll leave a link to a copy of this test in the description below. Now let's get started. Question 1, which value is equivalent to 700,000 plus 5,000 plus 200 plus 10 plus 9? And for this type of addition question, I recommend that you write the numbers out vertically. So I'm going to write 700,000 first, and then 5,000 I'm going to write underneath like this. And I'm going to make sure that I line up the place values. I wouldn't want to do something like this. Don't write your 5,000 all the way to the left like this, lining up the 7 and the 5. You want to make sure you're lining things up starting on the right. So then next we would have 200. So we have a 2 in the hundreds place. We have a 0 in the tens, and then a 0 in the ones place. And then we're going to add 10 and 9. So now we could just add everything up going down the columns, going from right to left. So we have 0 plus 0 plus 0 plus 0 plus 9 is 9. And then we just have 0 plus itself 3 times, and then plus 1 is 1. And then we have 0 plus 0 plus 2 is 2. 0 plus 5 is 5. And then notice that we just have a 0 here in this column over here. So I'm just going to carry down the 0, and then I just carry down the 7. Okay, so our final answer, we could throw in our comma. Remember, you throw in commas every 3 digits, starting from the right, going to the left. So our answer here is 705,219, choice B. Question 2, Jen runs 8 laps around a track and Carol runs 2 times as many laps as Jen. Which equation can be used to determine the number of laps Carol runs? So we're starting out here with Jen runs 8 laps around a track. And the $1 million phrase in this question is Carol runs 2 times as many laps as Jen. Now the word times tells you to multiply. Okay, so we are going to multiply here. And just think of something like 5 times 3. I could say 5 times 3, or I could say 5 multiplied by 3, and I could write out my equation here, 5 times 3 equals 15. So in this case here, if Carol runs 2 times as many laps as Jen, and Jen runs 8 laps, we're going to go times 2 here and say this equals blank. So all we have to do is look for the corresponding equation, and this is going to match up with choice D. If the question told us to actually solve it out, how many laps did Carol run? 8 times 2 is equal to 16, and that's where we're getting choice D from. The reason why it's not choice A, that would be correct choice A if they had said Carol runs half as many laps as Jen. Okay, so half as many laps, then we would divide by 2. If they said Carol runs 2 less laps than Jen, 2 less, then we would choose choice B. And if we were told Carol runs 2 more laps than Jen, then we would say 8 plus 2. But the word times says multiplies, so that's why it's choice D. Question 5, we want to know what is the product of 432 and 6. So product is just a fancy way to say multiply. Okay, so we are going to multiply 432 by 6, and we're going to use long multiplication. So we have 432 times 6, and now I just go from right to left. I'm doing 6 times 2 is 12. I write my 2, and the 1 in the 12 gets carried to the tens place. And now I have 6 times 3 is 18, and 18 plus 1 is 19. Okay, so I have 19, and then I carry my 1. And now I just repeat this process one more time. I have 6 times 4 is 24, and 24 plus 1 is 25. And I write my last set of digits here, and now I'm just going to throw in my comma to the right 3 places, and our final answer is going to be 2,592. Choice D is our answer. Question 6, which statement about an acute triangle is true? So when I hear the word acute, I think of just the word cute. And when you think of cute, I don't know, you could think of puppies or just anything tiny that's just absolutely adorable. And when I transfer that over to angles, and then I'll talk about what an acute triangle is, I think of an acute angle is just a small angle. Okay, so if I were to draw a small angle, let's say like this would be a small angle. The acute angle is less than 90 degrees. Okay, so less than 90 degrees, just think it's a small angle, it's cute, so it's an acute angle. So if I want to build an acute triangle, then all of the angles inside of the triangle are small angles. They are all less than 90 degrees. Okay, so now I just look through the answer choices. It has angles that are each less than 90 degrees. If it has an angle that's 90 degrees or more, just think that the angle is a big angle now, so it's a right angle or it's an obtuse angle that would be more than 90 degrees. And then those angles are no longer cute, okay? Or let's just say acute angles are the cutest angles. They're the smallest ones. So these are the ones here that we're interested in. So choice C is going to be our answer. Okay, A is out because a 90-degree angle is too much. If in choice B we have one angle that is greater than 90, this is not an acute triangle anymore. Now it's an obtuse triangle. So this one is out. If it has one angle that's exactly 90 degrees, this is a right triangle. So I'll just name the others. So right triangle, obtuse triangle, and if it has angles that are each greater than 90, this just does not exist. Okay, this type of triangle does not exist. The moment you try to draw two right angles in a triangle, you'll see here that it's no longer able to be connected with these sides, okay? Because if you have a right angle here and you have a right angle here, then these lines here are going to be parallel and they're never going to intersect. They're never going to touch, so you'll never actually be able to complete your triangle. You can make a four-sided figure. You can make something like a square or a rectangle when you have a few right angles, but you're not going to be able to make a triangle. So D is definitely wrong here. Choice C is our answer. Question 9, a pencil is shown below, and we want to know what is the length in inches of the pencil. So for a question like this, we want to take our ruler and we want to line it up at the beginning of the pencil, but we have to be careful. We have to make sure that we don't use the beginning of the ruler. We have to use the 0 line to start our measurement. So I'm going to move the 0 line like this to the beginning of the pencil. And then from here, I'm just going to mark off where the pencil ends. So we're going to stop our measurement right around here. And now we just have to know how to count by fractions. So here, I'm going to take the space from 4 to 5, and I'm going to cut it like this into 4 equal pieces. So you see here that we have 4 equal pieces. So this is 4. And then if I count by 1/4, this would be 4 1/4. This would be, I'll write it a little higher, 4 2/4. And 4 2/4, if I reduce the fraction part, I divide the top and bottom of this fraction by 2. 2/4 reduces to 1/2. Okay, so I could say 1/2 here. So I could say 4 2/4. This is the same thing as 4 1/2. And then next I would have 4 3/4. So this would be 4 3/4. And then if I write 4 4/4, so 4 4/4, this is basically saying 4 plus 1 whole. And that's where we're going to get 5 from. Okay, but remember, the pencil stopped at this location here, at 4 1/4. So that's why we're going to go with choice A. If I had to break this up into smaller pieces, let's say I want to know what is the value of this notch here on the ruler. Well, I'm going to jump from 1 to 2, but I'm going to count by the small spaces. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It takes me 16 jumps to get from 1 to 2. And this is 1, 2, 3 jumps. So this would be 1. I had to take 3 jumps out of the 16 total. So this would be 1 3/16 of an inch. Okay, so that's how you count along a ruler. But in this case here, we were counting by fourths, and our final answer is choice A. Question 10, which mixed number is equivalent to 13 thirds? So we're going to take 13 and divide by 3. And 3 goes into 13 4 times. I do 4 times 3 is 12. And now I'm subtracting 12 from 13. I have a remainder of 1. And the remainder I'm going to write over here. So I have a remainder of 1 goes in my numerator. And I originally divided by 3. So I have 4 1/3. And this is going to match up with choice C. If I wanted to check my answer, if I wanted to see if this does check out, just think about what this says as a division fact and then a multiplication fact. So if I'm doing 13 divided by 3 is equal to 4 1/3, then I could also say that 4 1/3 times 3 is equal to 13. And I could multiply here, or I could do the addition. I could do 4 1/3 plus 4 1/3 and then plus 4 1/3. And just so you know, this is something that may not be obvious, but 4 1/3, you could also write this as 4 plus 1/3. So let's say I really want to expand this out. I'm going to say 4 plus 1/3 plus 4 plus 1/3, and then I'll do one more, plus 4 plus 1/3. So I'm adding 4 1/3 to itself 3 times. And now with addition, the order does not matter. We say that addition is commutative, which means we could just add any order we want. So let's say I do 4 plus 4 plus 4. I would get 4 plus 4 is 8, and 8 plus 4 is 12. And then if I add the fractions together, I'm going to add these terms together now. I have 1/3 plus 1/3 plus 1/3. I add the numerators, 1 plus 1 plus 1 is 3, and I keep the denominators the same. And now this would give us 12 plus 3 divided by 3 is 1, and 12 plus 1 is 13. So this checks out. This shows here that our division was correct, that 13 divided by 3 is 4 1/3. Question 13, the line plot shown below represents the heights of 10 different plants. And here's the line plot, and we want to know what is the difference in height in inches between the tallest plant and one of the shortest plants. So for this question here, we have to look to the tallest plant would be where the final X appears. And the final X, if we go all the way to the right, ends at 7.5. Okay, so the tallest plant is 7.5 inches. And then the shortest plant would be where the first X's or the first X appears. And notice that we have 3 X's here on 5. So that means there are 3 plants that are 5 inches tall. But they're asking us for the difference in height between the tallest and shortest plants. So when you hear difference, this is telling you to subtract. We want to know how much taller is the tallest plant than the shortest plant. So we would do 7.5 and then minus 5. So for this one here, all you have to do is subtract the whole numbers here. So I'm going to do 7 minus 5 is 2, but the 1/2 has to carry along here. So 7.5 minus 5 is 2.5, and that is the difference in height in inches between the tallest and shortest plant. So choice A is our answer. Now, one thing to be careful of here, some students might look at this and say the smallest number on the line is 5 and the biggest number on the line is 8. And they might say 8 minus 5 is equal to 3 and choose choice B. But choice B is a very dangerous bear trap, okay? For line plots, you have to look for the X's. If there's no X here above 8, then that means there are no plants that are 8 inches tall. So choice A is our answer. Question 17, what is the rule for the number pattern shown below? Well, looking at this list, notice that the list is getting smaller. So I could eliminate right away choice D because multiplying by 2, if I'm starting with 64, would make the numbers get bigger and bigger. So choice D is definitely out. And now we could just go through the list here. So let's see, subtract 8. If we think about this, 64 minus 8, if we do the subtraction, is going to give us 56. And 56 is not the second number, so this is not the rule. We could just look for the pattern ourselves, or we could use the ones in the answer key here to see which one it is. So next, divide by 2. If we divide by 2, 64 divided by 2, I could find this by doing long division. I could do 64 and then go divide by 2 like this. 2 goes into 6 3 times. 3 times 2 is 6, and I subtract 6. I get 0, and then I bring down my 4. And then 2 goes into 4 twice. 2 times 2 is 4. I subtract 4. I have no remainder. That means 64 is evenly divisible by 2. And notice that my next number is 32. And if I do this repeatedly, if I do 32 divided by 2, so I'm just going to make this a little bit neater. So we have 32 divided by 2. I could run it through the same process, and I'm going to get 16, which is our third number. And then if I do 16 divided by 2, I'm using the same rule each time. I'm just dividing by 2. I get my next number. So this one is looking good. But why is choice C no good? Choice C is no good because if I do 64 divided by 8, 64 divided by 8 is 8. And remember, if you ever want to check your answer to a division question, you could just multiply these two numbers here. I could say 64 divided by 8 is 8, and I know that's true because 8 times 8 is equal to 64. But notice here that when we divided by 8, the next number we should get is 8, but the next number is not 8, it's 32. So that's why dividing by 8 is not it. Choice B is definitely the rule for the number pattern here. Question 19, what is the missing value in the equation shown below? And for this question, it helps to know that any whole number you could write as that whole number over 1. And for a case like this, 15, I could write 15 as 15 over 1 because 15 divided by 1 is equal to 15. So this is equivalent to what I started with. And now I'm going to write 15 times 1 over 6 as 15 over 1 times 1 over 6. And just know, anytime you multiply two fractions together, you can multiply their numerators together and then multiply their denominators together. So I'm going to do 15 times 1, and then I'm going to divide by the product of 1 and 6. Okay, so then I'm going to multiply the denominators together next. So we're going to do next up 1 times 6. And then from here, I just simplify. 15 times 1 is 15. And then I'm over 1 times 6 is 6. Now, there's a few ways that we could go from here, but to find the mystery value, let's think about this. All of the answer choices are whole numbers. So notice that when I did the multiplication here, the only value that changed when I multiplied was the numerator. I did 15 times 1 is 15, and my denominator stayed a 6. So here, if I have only whole numbers to choose from, which whole number times 3 is going to give us a numerator of 15? And if you look through the answer choices, it would have to be choice B. If I did 5 times 3, that's going to give us 15 and then over 6. If I want to check over here, I could say 5 times 3 over 6. I could rewrite this as 5 over 1, and now I use that same technique as before. I'm doing 5 times 3 in my numerator over 1 times 6 is going in my denominator. And then 5 times 3 is 15 over 1 times 6 is equal to 6. So that's why choice B is definitely correct. Question 20, Tiffany has 5 times as many red apples as she has green apples. If she has 20 red apples, how many green apples does she have? For this question, we have to be very careful. It's very easy for students to read through this very quickly and just go 5 times the number 20 and just say 20 times 5 is equal to 100, and then they choose choice D. But choice D is a very dangerous bear trap. With questions like this, the key thing is to stay very organized. One thing that I like to think about with questions like this to help me stay organized is I think about which type of apple does Tiffany have more of. She has red apples and green apples, and if we reread this question again very carefully, let's think about which one she has more of. So Tiffany has 5 times as many red apples as she has green apples. That means that she has more red apples than she does green. Okay, she has more of these type of apples than she does green. So if we're looking for how many green apples she has, and we're told here that she has 20 red apples, if she has more red apples than she does green apples, that means the amount of green apples has to be less than 20. So right away, we're down to these two answer choices. But now let's think about this. If she has 5 times as many red as she has green, that means we would multiply the number of green apples she has by 5 to get 20. So to undo this, the opposite of multiplying by 5 is dividing by 5. So watch what happens when we do 20 divided by 5. 20 divided by 5 is 4. So now let's say she has 4 green apples. And now we run this value for the green apples through the question. If Tiffany has 5 times as many red apples as she has green apples, now we do 4 times 5. And this would tell us that Tiffany has 20 red apples, which matches what they told us. So how many green apples does Tiffany have? She has 4 green apples. Choice A is our answer. Question 23, which figure appears to have exactly 2 lines of symmetry? Now, the key thing we have to be careful of is that the shape has to have exactly 2 lines of symmetry. So we're going to go through the answer choices one by one. A rectangle is going to have exactly 2 lines of symmetry. We could draw a line of symmetry straight down vertically, cutting this rectangle in half this way, or we could draw our line of symmetry like this horizontally, cutting the rectangle in half. Okay, so there are the 2 lines of symmetry. Now, a common mistake with a question like this is that students claim that there are more lines of symmetry. They say, well, what happens if I draw in the diagonal like this? But you have to be careful with this. A line of symmetry cuts a shape in half, but it also acts as a mirror line. So if I get rid of, let's say, this line here and this line here, why isn't this line here a line of symmetry? Because this wouldn't give us a mirror image of the rectangle. Notice that my right angle is over here in this space here. So if I reflected this through this line here that I'm claiming for a moment to be a line of symmetry, you could see that if this point looked in the mirror, it would appear to be this distance away from the mirror if it looked at its mirror reflection. But notice that this point does not appear on the rectangle, okay? It went through and away from the rectangle. So that's why the diagonals of a rectangle are not lines of symmetry. It will cut the area of a rectangle in half, but it is once again not a line of symmetry. So we could get rid of these and look at the remaining shapes, okay? So a rectangle has exactly 2. And that means choice A is our answer. But now, why are the other answer choices no good? a hexagon, and notice that this hexagon appears, the key word here is appears to have 6 lines of symmetry because it's drawn in such a way where all the sides and all the angles are equal in measure. So if we had to draw in all 6, we would draw in one line like this. We would draw in one line like this, okay, cutting the hexagon this way, and then we could cut the hexagon like this. Okay, so that's 3 lines. Right away, that's more than 2. But if I was looking for the other 3, then I would draw in a line like this, cutting through and connecting this point over here to this point here. I would connect these 2 points here that are opposite each other. So I would draw another line like this, and I'll just make this a little bit neater here. So I would just move this over just a bit. So that would be a better line of symmetry. And then I'd have one more here. So there would be 6 lines of symmetry total, as long as our hexagon is made in such a way that all of the sides and angles are equal in measure. Okay, there's actually a fancy name for it. We call this a regular hexagon. Okay, a regular hexagon just means all of the sides and angles are equal in measure. If I just drew a bad hexagon, or I maybe shouldn't call this a bad hexagon, if I drew one where the sides and the angles are not all equal in measure, then I don't necessarily have 6 lines of symmetry. Okay, I wouldn't have 6 lines of symmetry. So that's why choice B is not our answer, because it appears to have 6 lines of symmetry. Now, this is a regular pentagon. The 5 sides of the pentagon are the same, as well as the angles. So this would have 5 lines of symmetry. Okay, we would draw one line down like this, going through this point and cutting this side in half. I could draw one like this. That would be my second line of symmetry. I could draw one here like this, and then I could draw from my other point. So I have one here. So there's my 4th, and then my 5th would go like this, okay, cutting it in half. I would just have to draw this a little bit neater here. I'll just make sure that it lines up nicely with the point. But there would be the 5 lines of symmetry, but we want the one with exactly 2. And then a square is an enhanced version of this rectangle in choice A, because a square is a regular 4-sided figure. All 4 sides are equal. In a rectangle, the 4 sides are not equal in measure. So in a square, we can have these 2 lines that we had for the rectangle going this way and this way. But we could also have, I'm going to just draw this a little bit neater, we could have the diagonals counting as lines of symmetry. Okay, so I could have this one here going this way, and I could have this one going this way like this here. And if I had to just clean this up a little bit, of course, I would just try to aim this a little bit better so that it's very convincing that this is a line of symmetry. But a square would have 4 lines of symmetry, which is more than 2. So choice A is definitely our answer. Question 25, which angle has a measure of 60 degrees? And notice that 60 is less than 90. So that means we're looking for an acute angle. And remember, the acute angles are the small angles that are less than 90 degrees. So right away, I could see that choice B and choice C are out, that it's going to be either A or D. And now we could use a protractor here. And when you're measuring an angle with a protractor, you want to put the pointer here at the vertex or the turning point of the angle. So I'm going to put our pointer here like this. And then notice that the second ray that comes out of the angle is going to tell us the degree measure of the angle. So I just make sure that I line this up nicely here. And notice that it's pointing at, we have 1, 2, 3, 4, 5, about 6 degrees. Okay, this is a very, very small angle. Don't make the mistake of saying that this is 170 something, like let's say 100, we're going to count 1, 2, 3, 4. Don't say 174, because obviously 174 degrees would be an obtuse angle. That'd be a very big angle. It wouldn't be a tiny angle like this. So A is out, and just by process of elimination, it has to be choice D. But let's look over here. If we place the pointer here like this on the vertex of the angle, notice that the ray, the second ray that's coming up like this, is pointing to the 60 degrees here on the protractor. And one thing to note is that choice C is a trick answer here. Okay, this is a bit of a trap. That notice that this second ray here that's coming up this way is pointing at 60, but we have to recognize that this is an obtuse angle. It's more than 90 degrees. So we're going to go with this number here, 120. That would be the measure of the angle in choice C. And if we look over here at choice B, this is just a right angle, but if we line up here, notice that this lines up with 90 degrees. So our solution to question 25 is going to be choice D. Question 29, the shaded part in the model shown below represents a fraction of the whole model. Which fraction is equivalent to the value represented by the shaded part in the model? Now, with fractions, it helps to think of fractions as part over whole. The numerator we call the part, the denominator we call the whole. And if you want a better way to think of this, if you enjoy pizza, so if we want to use a pizza analogy, what we could say is that the numerator is how many slices you eat. Okay, so how many slices you eat. And the denominator is the total number of slices. Okay, so the total number of slices. Most pizzas that you'll get are going to have 8 slices. So let's say you have a pizza and you eat out of the 8 slices. Let's say you had 3 slices, which would be a lot of pizza. Okay, so 3 slices. That means you ate 3 slices out of the 8 total. Okay, so this is if we were thinking about it in terms of pizza. But it also works too if we have these type of diagrams here. Just think of this maybe as a Sicilian pizza, the square pies. So here, let's just say the shaded ones are the ones that we eat. We ate 2 slices out of how many slices are there in total? 1, 2, 3, 4. So you get 2/4. However, with fractions, you want to reduce your fractions. So you might look at this and say, oh no, my answer is not there. Well, that's because 2 and 4 are both divisible by 2. They have a common factor between them. So we could divide the numerator and denominator by the same value 2 here. And now we just do the division. 2 divided by 2 is 1. 4 divided by 2 is 2. So our answer here is going to be choice C, 1/2. You could also just get through this question very quickly. You could just look at this and say, oh, half of the total boxes are shaded. So this model represents 1/2. But I just wanted to show here the technical way of how to reduce our fractions as well. But in either case here, we're getting choice C. Question 30, what is the value of 7,225 divided by 6? So for this question, we're going to set up our long division like this. And one thing to be on the lookout for is some of the answer choices have remainders in them. So that means we just have to be extra careful when we do this division here. So let's start the process. We're going to do 7 divided by 6. We could get as close as 1 times 6. If I do 1 times 6, I get 6. And when I subtract, I have a remainder of 1. I couldn't say something like 2, because if I did 2 times 6, that would be 12, and that would put us past 7. So I have to get as close as possible to this number without going over. And now I bring down my 2, and I start the process all over. 12 divided by 6 is 2, and 2 times 6 is 12. Remember, 12 divided by 6 divides evenly, gives us exactly 2. So when I subtract here, I have no remainder, but then I bring down my 2, and I start the process all over again. I keep going until I run out of digits. So then next, I'm doing 2 divided by 6. But the problem here, if we think about our 6 times tables, so let's think about this. The 6 times tables, if I start at 0, I have 0 times 6, 1 times 6, 2 times 6, 3 times 6, and so on. The problem here is that I only get to 2 if I start at 0. I can't go to 6 times 1 because that puts us past 2. So I have to start here at 6 times 0. So I would say 2 divided by 6, I could get as close as 6 times 0. And then that's going to give us this same remainder of 2. And it might seem like we're getting nowhere, but watch what happens when we bring down the 5. Now we could say 25 divided by 6. The closest we could get to 25 is 6 times 4. So I put my 4 here. 4 times 6 is 24, and I subtract. And now I have no more numbers to bring down. So my remainder is 1. The better way to write this for later is 1204, and my remainder 1 is going over my divisor 6. Okay, so this is the nicer way to write your answer, but this has its use later on in math as well. So now we just scan the answer choices here, and we could see our solution is 1,204, remainder 1, choice B. Question 31, in which triangle does the dotted line appear to be a line of symmetry? Remember, a line of symmetry has to act as a mirror line. That means that if I fold any point the same distance over the line, it has to land on another point on the triangle. So notice here that when I fold this red point over the dotted line, that it's going to land here. If I fold any of the other points, like let's say this point here, if I fold that over the line, it's going to land here. So any one of the points on the triangle, when we fold it over the dotted line, is going to land on the other side perfectly. So choice B is going to be our answer. Now, the one thing that I look for in these questions is I look for a shape that has a lot of symmetry to it. So this is an equilateral triangle. It has 3 sides that are equal in measure and 3 angles that are equal in measure, or at least it appears to be all equal in measure going around. So this triangle has a ton of symmetry. So that's why choice B here just immediately jumps out. Choice A, what I don't like about choice A is that this triangle here, the 3 sides are not all equal in measure. So you could see here that when we draw this line in like this, let's say I were to fold this point over the dotted line. It's going to land somewhere over here, and notice that it misses the triangle completely. So that's how I know choice A is out. This is not a line of symmetry for the triangle in choice A. Now, the problem with choice C is that the location of the dotted line is no good. If I were to fold this triangle over the dotted line, let me pick a point like this. If I continue this line like this, going this way, you can see this point, if I fold it over the dotted line, is going to land somewhere over here. It's going to miss the triangle that we started with. So that's how I know choice C is no good. If I wanted to make choice C the answer, I could draw the line of symmetry like this. I would start here at this point and I would go this way. This would act as a line of symmetry. This is a right triangle and it looks like these 2 sides are equal in measure. This looks like an isosceles triangle. And in this case here, if I drew my line of symmetry like this, choice C would be good. But the way the line was drawn originally, this line of symmetry, this is not a line of symmetry. So choice C is out. And now for the remaining answer choice here, choice D, this one here is no good. This is a scalene triangle. All 3 sides are different. Okay, they are not equal in measure. So if I look here at one point that would rule this out right away, I'm seeing this point over here that if I go the same distance to the line, I go through the line. See, that would put this point over here. Somewhere over here, it misses the original triangle. So choice B is definitely our answer. Question 32, which comparison is true? And for choice A, we have 1/4 is less than 2/8. So there's 2 strategies we could use for fractions when we're trying to compare which one's greater than or less than the other. So one way is to get the denominators to match. So when I think of something like 1/4 is less than 2/8, I focus on the denominators. So I have a denominator of 4 and a denominator of 8. And I think about how could I get them to match? I think of the least common multiple between both of those numbers. So if I start counting by 4s, I have 4, 8, 12, 16, and so on. And if I start counting by 8s, I have 8, 16, 24, and so on. But where do these lists match for the first time? They match at 8. So I would turn this denominator into an 8 by multiplying the denominator by 2. But if I multiply the denominator by 2, I have to multiply the numerator by 2 as well. And the reason why this doesn't change the value of the fraction is because 2 divided by 2 is 1. So I'm really just multiplying this fraction by 1. I'm only changing the representation. I'm not changing the value. So then I do 2 times 1 is 2. Over 2 times 4 is 8. And now let's think about this statement. Is 2/8 less than 2/8? No, this statement here is not true. 2/8 would be equal to 2/8. Okay, those are equal values here. I can't say that 2/8 is less than 2/8. So I move on to the next answer choice here. So now we have 1/3 is greater than 3/6. So the next method we could use, if we don't want to use the common denominator method, is we could just draw diagonals in like this and multiply. So I could do 6 times 1 is 6, 3 times 3 is 9. And now I think about the values here and think which number is bigger. 9 is bigger than 6, so that means this would be the greater fraction. 3/6 is greater than 1/3. And the way to remember the inequality sign is just, I like to imagine the Pac-Man, that if I have 1/3 and I have 3/6, and you would want the Pac-Man's mouth to be facing the greater amount, okay? The Pac-Man would want to eat the bigger amount here. Some people use an alligator or something, whatever animal makes you happy. Just know that the animal wants to eat the greater fraction. So that's the way the mouth faces. It wants to eat more, okay? So that tells us choice B is no good because 1/3 would be less than 3/6, not greater than. So now we move on to choice C. 3 over 6 equals 5 over 8. So for this one, we could use the common denominator method if we want, or we could reduce and then get them to match. We could use that cross diagonal method that I just showed here, whichever one makes you happier. But let's say we go for the common denominator method. So I'm starting out with this. And now the least common multiple of 6 and 8 would be 24. I would have to do 6 times 4 to build 24, and I would have to do 8 times 3 to build 24. So now I'll write the new result here. 4 times 3 is 12, over 4 times 6 is 24. And then we have to ask ourselves, is this equal to 5 times 3 is 15, over 8 times 3 is 24? So now that our fractions have the same denominator, we just have to look at the numerators here. And 12 and 15 are not equal. So that choice C statement here or equation here is not true. So just by process of elimination, it has to be choice D. But let's see why. If I have 2/3 equals 4/6, what I could do here is, let's say I reduce the fraction on the right side. I divide the top and bottom by 2. Now I have 2/3 equals 4 divided by 2 is 2, and 6 divided by 2 is 3. 2/3 equals 2/3 is a true statement, so choice D is our answer. Question 33, which statement about the figure shown below is true? And we have this triangle over here. And for choice A, it says it appears to have all acute angles. Remember, acute angles are less than 90 degrees. Those are the small angles. But notice over here that this angle is exactly 90 degrees, at least the way that it is drawn. So we can see here we have a right angle here. This is a 90-degree angle. So choice A is not our answer because here's at least one angle that is not less than 90. Choice B, it appears to have all obtuse angles. Obtuse angles are greater than 90 degrees. And notice that 90-degree angle proves choice B wrong. Okay, this triangle here has a 90-degree angle and 90 is not greater than 90. Also, it is impossible for a triangle to have more than one obtuse angle. Okay, a triangle could only have one obtuse angle. If it had more than one obtuse angle, it would need more sides to connect. It couldn't be connected with 3 sides then, so B is out. Choice C, it appears to have 2 parallel sides. The problem with choice C is that if you drew 2 parallel lines over here like this, notice that the only way to close this would be to draw in 2 more lines. If I connected like this, notice that this part here is still open. I would have to draw in another line segment like this and connect. And then I would have a 4-sided figure, but it would not be a triangle anymore. It would be a quadrilateral, a shape with 4 sides. And then next, it has to be choice D, but the figure here appears to have 2 perpendicular sides. This is a fancy term. Perpendicular means that the 2 lines are going to intersect and make a 90-degree angle. Okay, so the 2 sides form a 90-degree angle, right? That's what it means for 2 line segments to be perpendicular. Okay, they form a 90-degree angle. Later on, you'll see that when you have perpendicular lines that are not forming any type of closed shape, that they're just going to form 90-degree angles like this. Okay, but remember, when you hear the phrase perpendicular, you're looking for 90-degree angles. So that's why choice D is definitely our answer. Question 34, Tim has 3 packs of markers and each pack has 12 markers. Which equation can be used to find the total number of markers n that Tim has? So for questions like this, it helps to draw this out. So if Tim has 3 packs of markers, so here are the packs of markers, and each pack has 12 markers, we could use this visual display here to set up our equation to find the total number of markers n that Tim has. So here, notice that if each pack has 12 markers and there are 3 packs, we could do 12 plus 12 plus 12 to find the total number of markers n. But remember, repeated addition is multiplication. So I could say n is equal to 12 plus 12 plus 12, or I could say that n is equal to 12 times 3. Now, one thing we need to know about multiplication is that the order does not matter. I could say n equals 12 times 3, or I could say that n is equal to 3 times 12. So now I just look through the answer choices here, and I can see that 3 times 12 equals n matches what we have here. Now, technically, we flip things over here like this, but if n is equal to 3 times 12, I could say that 3 times 12 is equal to n, you are allowed to flip the left and right side of an equal sign. You could just move the terms like this. I just move all of the left to the right, and I move everything on the right to the left like this. I just make a swap, and that shows us that choice B is our answer. Question 35, our last multiple choice question. We want to know what is the value of 24 times 11. And for this question, we could use long multiplication. We're going to do 24 times 11, and we could start off by multiplying the 1 across. So we're going to do 1 times 4 is 4. 1 times 2 is 2. But then when we go to the next row, we're multiplying from the tens place. So we have to put a 0 as a placeholder in the ones place here. And now we start all over again. We have 1 times 4 is 4. We have 1 times 2 is 2. And now we just do the addition here. We're going to add this stuff up. We have 4 plus 0 is 4. 2 plus 4 is 6. And then the 2 just carries down. This product is equal to 264. Choice C is our answer. Question 36, Rosie combined 1 3/4 gallons of cranberry juice and 3/4 of a gallon of apple juice to make fruit juice. And we want to know how many gallons of fruit juice did Rosie make with the cranberry juice and apple juice. So here we're just going to be adding the mixed number 1 3/4 and the fraction here 3/4. So for this one here, it helps to know the concept. A mixed number, we could express one other way here. We could write this as 1 plus 3/4. So we're really doing this addition problem here. We have 1 plus 3/4 plus another 3/4. So this is one option. Another option is to turn the mixed number into an improper fraction. But for a question like this, I would prefer to do it this way. So now what we have is I'm going to leave 1 alone. And first I'm going to add 3/4 plus 3/4. And notice here that these two fractions have the same denominator. So I can combine these two fractions here by just adding their numerators. I'm going to have 3 plus 3 and then over 4. I'm just once again adding the numerator of the first fraction and the numerator of the second fraction, and we keep the denominator the same. So now this would simplify to, we'd have 1 plus 6 over 4. And for this one, I want to express 6 over 4 as a mixed number. So I'm going to do the long division on the side here. I'm going to have 6 divided by 4. And 4 goes into 6 one time. That's as close as we could get. And we have 1 times 4 is 4. And when we subtract, we have a remainder of 2. But the remainder of 2 is going to go in the numerator. And our original divisor here, 4, goes in the denominator. So this now we could say is going to be equal to, we have 1 plus, and then we have 1 2/4. So 1 2/4 I could write like this. And just know here that 2/4 we could also reduce. 2/4 reduces to 1/2. If I divide the top and bottom of my fraction by 2, 2 over 4 reduces to 1/2. So now what I could do here is I could say that this is 1 plus 1 1/2. And when you add a whole number and a mixed number like this, all you have to do is just add the numbers in front. So I'm just going to add 1 plus 1 here, and the 1/2 is just going to tag along. So I have 1 plus 1 is 2. So our final answer here is going to be 2 1/2. Now, one other way to add these two numbers together would be to take the mixed number that we're starting with here and to convert this to an improper fraction. When you want to convert a mixed number to an improper fraction, what you want to do is you want to take the denominator and multiply it by the whole number in front. So I'm going to have 4 times 1, and then I'm going to add the numerator. Okay, so I have plus 3, and then I keep my denominator the same. I'm keeping my denominator over 4. And then I'm just going to write the plus 3/4 next to it. So then from here, I have 4 times 1 is 4. So next I could do 4 plus 3 is 7. So that's going to give us the first fraction simplified is 7 over 4. Okay, so we have 7 over 4 plus 3 over 4. And for this one, notice that what we have here is two fractions with the same denominator. So I could add 7 plus 3 is 10, and I get 10 over 4. And now if I do the long division on the side here, 10 over 4, 4 goes into 10 twice. 2 times 4 is 8. And when I subtract 8, I have a remainder of 2. And my remainder goes in the numerator, and my divisor goes in the denominator. And 2 2/4 simplifies to 2 1/2. So either way, I get 2 1/2 gallons. That's our solution to this question here. Question 37, what is the number 88,678 rounded to the nearest thousand? So for this question, we have to know the place values of each of these numbers. So we have the ones, the tens, the hundreds, the thousands, and the 10,000s place. And this could continue on, but we're stopping the number here. And we want to round to the nearest thousand. So the first thing I do is look for the number in the thousands place, and that's an 8. And then when we're rounding, we want to look to the right of the number we highlighted. So we're looking to the right and notice that it's a 6. And if the number to the right is 5 or higher, you round up to the next, in this case, 1,000. So after 8,000 would be 9,000. So we're going to round this number to 89,000. Okay, so we're rounding to 89,000. So here's our solution to 37. Now, before we move on, I want to think about the concept behind this question. Let's think of the number line. And I'm going to count by thousands. So I'm going to start here at 88,000. And then I'm going to go next to 89,000. And then after 89,000, if I'm counting by thousands, would be 90,000. And let's think about where is the number 88,678 located. It would be at about this location over here. Okay, so I'm just imagining that this number that we're starting with, 88,678, would be more than halfway from 88,000 to 89,000 because we have 678. So 500 would be about here, 88,500. So 88,678 would be a little bit more to the right. And then ask yourself, which number is this number closer to? Is it closer to 89,000 or 88,000? Notice that it's definitely closer to 89,000. That's why we're rounding to 89,000. So our solution here is 89,000. Question 38, how many 1-degree angles are there in a complete circle? So for this question, it helps to know that there are 360 degrees in a full circle. So if we wanted to see here how many 1-degree angles there are in a complete circle, well, all we'd have to do is just look at the center, and we could just go ahead and start drawing in 1-degree angles and count all of them, but we would be here for a really long time. So there's got to be an easier way. So just think, if we're counting by ones, and in total there is 360 degrees in a circle, technically we could say 360 degrees, and we want to know how many 1-degree angles are there in a complete circle. We could divide by 1 degree. Okay, we want to see how many times could I jump by 1 degree until I get to 360. But 360 divided by 1 is just 360. So there are 360 1-degree angles in a complete circle. So our solution here, there are, once again, 360 1-degree angles. Question 39, which quadrilaterals shown below appear to be rectangles? Be sure to include what you know about angles and sides in your answer. So for this question, let's go through the quadrilaterals one by one and see which ones appear to be rectangles. So quadrilateral A is a rhombus. It is not a rectangle, and if you notice here, this angle up top appears to be an obtuse angle. It's more than 90 degrees. And for a quadrilateral to be a rectangle, it needs to have 4 right angles. So A is out. This one here is not a rectangle. If we look at quadrilateral B, this angle over here also looks obtuse, and this angle would be more than 90 degrees, so this is not a rectangle. This one just looks like a parallelogram. Now for choice C, notice that we have 4 right angles. So right away, this quadrilateral has all of the properties of a rectangle, but they did say be sure to include what you know about angles and sides in your answer. And notice that the opposite sides here appear to be equal in measure. Okay, this one here looks like a square, but a square has all of the properties of a rectangle, so we are going to include this in our answer. Now for choice D, this is a trapezoid. A trapezoid has 1 pair of parallel sides. So see that these 2 sides here are parallel, but the other sides over here are not parallel. We do have a right angle here and here, but this angle over here is obtuse. And once again, for a quadrilateral to be a rectangle, it needs to have 4 right angles. So D is out. So far, we just have C is a rectangle. And then next we have for E, this one here is a rectangle. So if we look, we have 1, 2, 3, 4 right angles, and both pairs of opposite sides are equal in measure. So we could say that C and E are rectangles because they have 4 right angles each, and both pairs of opposite sides are equal in measure. Now, one thing to point out, technically the first sentence would be enough to establish that we have 2 rectangles. Once you know that you have a quadrilateral with 4 right angles, that automatically makes it a rectangle, but they did say to mention something about the sides. So I just mentioned here that we have two pairs of opposite sides that are equal in measure. Question 40, a student draws the two rectangles shown below. The student thinks the two rectangles have the same area but different perimeters. Is the student correct? And we have to be sure to include the areas and perimeters of both figures in our answer. So for this question, it helps to know the formula area equals length times width. This is the formula you want to use when you're finding the area of a rectangle. So first we could find the area of rectangle A, and then we'll find the area of rectangle B. So let's just say here that the length is 8 and the width is 5. So if we plug in here, we're going to have 8 times 5 is equal to 40. Okay, so the area is going to be 40 square units. And then for rectangle B, let's say that the length is 4 and the width is 10. So if we plug into the area formula for rectangle B, we're going to have 4 times 10 is equal to 40. Okay, so 4 times 10 equals 40. So notice that these two rectangles do have the same area. So far this student is correct. The next thing we want to find here is the perimeter, which is the distance going all around the shape. So in a rectangle, the opposite sides are equal in measure. So this missing side over here, I could label with a 5 because directly across from it, this side over here going across from left to right is 5 units long. And now the vertical side here, the one going up and down, I could label with an 8 because this side over here is an 8, and I'll just make this a little bit neater. So this side is 8 units long. And then in rectangle B, this side over here is 10 units long, and this one is 4 units long. So now we'll go ahead and find the perimeter of rectangle A. So I'm going to look over here, and we're going across 5. So we're going to do 5 plus. And after this, now we look at the next side that we're adding. We're going to have 8. So we're going to do 5 plus 8. And then we're going to add another 5. So we're going to do this side here, the third one. And then one more time, we're going to add an 8. Okay, so this would give us all 4 sides. I like to keep track as I'm doing this. With a rectangle, it's not too bad because there's 4 sides, but if you have a complicated shape later on that has many sides, it helps to highlight it as you write it out so that you don't forget how many sides you wrote so far. So now I just add here, and remember, the order in which you add does not matter. Addition is commutative. You could choose to add any two numbers you want first. So let's say I do 5 plus 5 first, because 5 plus 5 gives us 10, and it's a lot easier to add 10 to a number than it is to do, let's say 5 plus 8 is 13, and then do 13 plus 13. So I have 5 plus 5 is 10, and if I add the 8s, 8 plus 8 is equal to 16. So now when I do 10 plus 16, I get 26. So the perimeter of rectangle A is 26. And now I'm going to find the perimeter of rectangle B. So in this case here, I'm going to do 10 plus, so let's say I start with this side up here, so I'm going to add 10 first, and then I'll add 4 next, so I'm going to go plus 4. And then after, I'll add another 10. So I'm going to add this one. So we have plus 10. And then we have one more side to add. We have the side that's 4 units long over here on the left. And that covers all 4 sides of the rectangle. So now I'm going to do first 10 plus 10 is 20. And then I'm going to do next 4 plus 4 is equal to 8. So I have 20 plus 8. And 20 plus 8 is 28. And notice that these perimeters are not equal. Okay, so that tells us here that these rectangles do have the same area, but their perimeters are different. So this student is correct. Question 41, what fraction can be added to the expression shown below to have a total value of 1 whole? So for a question like this, the first thing I would do is add the fractions together. So we have 2 over 12 plus 7 over 12. And notice that these two fractions have the same denominator. So since they have common denominators, we could add these fractions just by adding the numerators together and keeping the denominator the same. So we have 2 plus 7 and the numerator is 9 over 12. And now for this here, what we could do is we could subtract this fraction from 1 because the question is asking what fraction can be added to the expression shown below to have a total value of 1 whole. Okay, so 1 whole means we want to build this up to equal 1. So if we want to know how far away we are from 1, we could subtract. So we could do 1 minus 9 over 12. And one thing we could do ahead of time though is just reduce this fraction so that the numbers that we're dealing with are easier. So notice that 9 and 12 have a greatest common factor of 3. So I could divide the top and bottom by 3, and this reduces the fraction to 3/4. So you might just be able to do this part in your head and see how far away you are from 1. Notice that we're missing 1/4 to make this fraction whole. Okay, otherwise what we could do is we could do 1 minus 3 over 4. And then for this one here, we would just have to find common denominators. So here I would write 1 as 1 over 1 minus 3 over 4. And for this, I would find common denominators by multiplying the top and bottom by 4. And then notice what we would have next. 4 times 1 is 4. Over 4 times 1 is 4. So we have 4 over 4 minus 3 over 4. And now that we have common denominators, we can subtract here. And we're going to keep the denominator the same. And we're going to subtract the numerators. So we have 4 in the denominator, and we have 4 minus 3 in the numerator. And 4 minus 3 is 1. So the missing fraction here is 1/4. So our final answer here is 1/4. Question 42, Stacy played the same game 2 times. She scored 36 points in the second game, which is 4 times as many points as she scored in the first game. How many points did Stacy score in the first game? So for this question here, let's think about what's going on here. Stacy plays some game 2 times. So let's think about the first time and then the second time. So in the first attempt here, we have Stacy played some game, and we don't know how many points she scored the first time, but we do know that she scored 36 points in the second game. What they did tell us, though, is that this was 4 times, so 4 times as many points as she scored in the first game. So really think about this. If she has some point value here, and to get from the first game to the second game, we're going to multiply that by 4. How do we go from 36 backwards? Well, if we had some mystery value and to go forward we go times 4, to go backwards, the opposite of multiplying by 4 would be to divide by 4. So we could do 36 divided by 4, and 36 divided by 4 is 9. So this tells us that Stacy scored 9 points in the first game. But how do we know our answer is correct? Well, we could run it back through the question. If we take her points in the first game, 9, and multiply it by 4, or do 4 times 9, we're going to get 36, which equals the amount of points she scored in the second game. Question 43, Miss Leonard has $110 to buy bottles of craft paint at the store. Each bottle is $9, and we want to know what is the greatest number of bottles of craft paint Miss Leonard can buy with the amount of money she has. So for this question here, we're going to take Miss Leonard's total amount of money, which is $110, and I'll just write 110 here, and we're going to divide by 9. That is the cost of each bottle of craft paint. So from here, we do the division, and we have 9 goes into 11 just 1 time. And if I do 1 times 9, I get 9. So I subtract 9. I have a remainder of 2. And now I bring down the 0, and I say 9 goes into 20 twice. I could only get as close as 9 times 2, which is 18. And when I subtract, I have a remainder of 2. So we have a remainder of 2 here. So the concept behind what's going on here in the context of this question is that Miss Leonard could buy just 12 bottles of paint. She cannot buy the 13th bottle because she would have $2 left over. And they wouldn't allow her to buy part of the paint. She can't just say, oh, I can't afford the whole thing. Let me just pour some of it on the floor and just buy part of the bottle. She could only buy a whole bottle here. So even if we were really close to having $9 for the next bottle, she just can't afford it, means she can't buy it. So if you think about this on the side here, once again, the concept, if we do 9 times 12, 9 times 12 is 108. If I did 9 times 13, I just add 9 more to this, I would have 117. But notice here that 117 is more money than what Miss Leonard has in her pocket or in her bag. Okay, so this tells us here that Miss Leonard cannot afford the 13th bottle. She could only afford 12 bottles here. So the greatest number of bottles of craft paint that Miss Leonard can buy is 12 bottles. Question 44, our last question. We have Mr. Benson is making burgers based on the information below. He has 4 pounds of meat. He uses 1/4 of a pound of meat for each burger, and he makes 9 burgers. How many pounds of meat does Mr. Benson have left over after making all the burgers? So for this question here, let's go ahead and find the actual answer, and then we'll explain how we determine the answer. So for this one, we have the total amount of meat is here in the first line. But then we know that Mr. Benson is going to use 1/4 of a pound of meat for each burger, and he's making 9 burgers. So the first thing I would do is do 9 times 1/4, and that would tell us how much meat Mr. Benson is going to use to make all of the hamburgers. So when we multiply a whole number by a fraction, we could write the whole number 9 as 9/1. And now to multiply fractions, we're going to multiply the numerators and the denominators. So I'm going to do 9 times 1 is 9, over 1 times 4 is 4. And then from here, what we could do is we have this much meat is being used. Okay, so this is the amount of meat that is used. So the amount, I'll just abbreviate, of meat that is used. So if we want to think about how much meat is left over, we have to look at the total here, okay? The total amount of meat is 4 pounds. So the leftovers is going to be the total minus the amount that is used. So we're going to do 4 minus 9/4. But in order to subtract these numbers here, we need common denominators. So I'm going to write 4 as 4/1, and I need to get a denominator of 4 out of this. So I'm going to multiply this fraction here by 4/4. And now we could transform this. We have 4 times 4 is 16, over 4 times 1 is 4, and we're subtracting 9/4. So now we just do the subtraction here, and 16 minus 9 is 7. And then we keep the denominator the same here. When we subtract or add fractions, remember, you keep the denominators the same. So now we would just have to divide this out. If you could do this part in your head, then great. If you just know that this is 1 3/4, then awesome. Otherwise, what we have to do is do the long division here. So we have 7 divided by 4. 4 goes into 7. We could get as close as 1 times 4, which is 4. If we did 2 times 4, we would get 8, which goes past 7, and that would be no good. So we have 7 minus 4 is 3. That is our remainder, and that's going to be the numerator of our fraction, and our denominator is going to be the divisor here, 4.